Now here the problem is a social club has 15 members, of whom 8 are men and 7 are women. The committee of the club consists of 5 of its members. Find the number of different ways in which the committee can be formed from the 15 members if it must include more men than women. Okay. So the committee should have more men than women. Now 5 members should be there in a committee. 8 are men and 7 are women. So it could possible that I have all 5 men. So the conditions we can discuss is like 5 men and 0 women, or 4 men, 1 woman, or 3 men, 2 women. That's it. These 3 conditions. Okay, so now 5 men and 0 women. So 5 men out of 8 men. Find the number of different ways. No? So out of 8 men, 5 men can be chosen in 8C 5 ways. Right? 0 women means 8C0, 8C0 is 1. Then 4 men, so out of 8 men, we choose 4 men, and out of 7 women, we will choose 1 woman. Or here it is like out of 8 men, we will choose 3 men, and out of 7 women, we will choose 2 women. So this first part will give me 8C5, it's 56, then 8C4 times 7C1 is 490, and 8C3 times 7C2, that is 1176. So the total arrangement will be 1722. Okay, this is A part. Now second, 15 members are having their photograph taken. 15 members are having their photograph taken. They stand in 3 rows with 3 people in the front row, 5 people in the middle row, and 7 people in the back row. And how many different ways can the 15 member of the club be divided into a group of 3, a group of 5, and a group of 7? So we have to understand that in how many different ways can the 15 member be of the club be divided into a group of 3. So in group of 3, so out of total 15 member, if I see group of 3, how many group of 3 possible? So it is 15C3 group of 3 possible. Then once 15 members are 3 members are selected, then I have only 12 members. So out of 12, now this time I will make a group of say 5 people, and then the remaining 7 peoples, okay, they will make a group of 7, so that is going to be 1 only. So here 15C3 is 455, 12C5 is 792, and 7C7 is 1. Okay, the total here actually I must multiply, no? Not add. Why I'm adding? Because first 3 I will arrange and then I will arrange 5 and select 5 and then I will select the remaining 7. So they will multiply with each other. So here there is multiplication and multiplication. So the total order will be total and selections will be 455 times 792, which is 360, 360. So in how many different ways? Okay. So required number of ways, I will say therefore required number of ways is equals to 360, 360. Then okay. Now in one photograph, Abel, Betty, Kelly, Doe, Eve, Freya, and Gino are the 7 members in the back row. And how many different ways can these 7 members be arranged so that the Abel and Betty are next to each other and the Freya and Gino are not next to each other? So what we can do, if Abel and Betty we will consider next to each other, then the total number of arrangement uh, will be of like 2 times 6 factorial, right? Why 2 times 6 factorial? Because Abel and Betty are together, so then we can consider that there are 6 members and they can arrange themselves in 6 factorial ways. But Abel and Betty they can change their position. Okay. Now in this I also considered the cases when Gino is next to Freya, but I do not want that case, so I have to subtract that. Okay, so I have to subtract that. So when I consider Gino and Freya also together, then that time what will happen? That Gino and Freya they will also consider to be one, so it will become 5 factorial, and in that 5 factorial 2 factorial I will multiply, I will or sorry, I will multiply by 2 this 5 factorial. I will multiply by 2 to indicate that Abel and Betty can change their position, and I will again multiply by 2 to indicate that the Freya and Gino can change their position. So if I see this is 2 times 6 factorial, where is that factorial notation? Okay, yeah, minus 4 times 5 factorial is 120. So 960. So for C, the number of options I have 960. Okay, that's it.